Just waiting for it to start recording. Being very slow. Okay. Hi, everybody. Today we are working on our lesson 11 from module 5. Today we're going to be finding the area of rectangles with mixed numbers, so whole numbers and fractions. We're going to be drawing some diagrams to show tiling, and then we're going to do some fraction multiplication along with that. So how the problems that would have worked in school is a little bit different than how we're going to do it here today. So some of the directions may not totally make sense with how we do it, but just follow along with me in the video. Okay, so we're going to draw a rectangle and some tiling, which is basically just drawing blocks or boxes to show how big the rectangle is. So for your first rectangle, draw something about that size. So I use up most of that space there. Okay, so what I'm going to do is I'm going to partition this side into 2.5. Sorry, I shouldn't have drawn that the whole way. So basically, I'm drawing two lines. So these are a bit wider, and this one I meant to make about half as wide. So this represents 2, and then this side, this represents 1/2. So this whole side is 2.5. So you want to draw that on your paper. And then the other side I'm going to represent 4.5. So I'm going to draw 4 full-size columns and then 1/2 of a column. So that's 1, 2, 3. And then this one I have to have a hole and a half. So I want to make sure that I'm trying my best to make the last one a little bit thinner. But even if it's not, I still can label these 4 as 4 holes. And then I can label this one as 1/2. So we basically kind of did almost like a number bond. So this side was worth 4.5. I separated the 4 holes from the 1/2. So, and if you want to help yourself visualize that a little more, you can kind of make this line that separates the holes from the halves a little darker. And then same thing on this side. So when I make those lines darker to separate the holes from the halves, you can kind of see we have an area model here. Any questions on what I've done so far? Okay, so rectangle A is blank units long, blank units wide. So the length is 4.5, and the width is 2.5. We have to find the area. Does anyone remember how we find area? What's the formula for area? What two things are we multiplying?
Length and width. Yeah,
length times width. Good job. Okay, so we are going to be multiplying 4.5 times 2.5. So I'm going to use my workspace down here. 4.5 times 2.5. Okay. So the first thing I'm going to do is I'm going to multiply my 2 whole numbers. So that'll be 4 times 2. Then I'm going to do 4 times 1/2. And then I'm going to do 1/2 times each of these parts. So 1/2 times 2 and 1/2 times 1/2. So if I want to use my model here, the first thing I did was 4 times 2. That's finding the area of this block right here. That's 4 times 2, this first large section. The next thing I did was 4 times 1/2. So that's finding this area of this short and long rectangle. Then 2 times 1/2, because this length is 2. So this part is 2 times 1/2, which is what we did here. And then the last one is 1/2 times 1/2. So it's really just an area model, or you can think of it as the distributive property, whichever one mentally makes more sense for you. So then we're just going to go through and start solving what's inside these parentheses. So 4 times 2, that is 8, plus, okay, now I have 4 times 1/2. So I know that that's 4 times 1 over 2. Because that's 4 times 1 over 2, which is 4 over 2, which is 4 divided by 2, which is 2. So this set of parentheses equals 2. Okay, next I have 1/2 times 2. So that would be 1 times 2 over 2. So 2 over 2, that's equal to 1 whole. And then 1/2 times 1/2. So 1 times 1 is 1. 2 times 2 is 4. Now that I've solved the inside of each set of parentheses, I just have to add these together. So 8 plus 2 plus 1. So 8 and 2 is 10, plus 1 is 11, plus 1/4. This is 11 and 1/4. So the area is 11 and 1/4 units, square units. Okay, that was a lot of steps. So let's do another one. For rectangle B, this one's going to be, I'll give you the length and the width. The length is going to be 3 3/4. And the width is going to be 1 3/4. Okay, so for the length, I want 3 full-size boxes and then one that's just a little smaller for 3/4. So 1, 2, 3 3/4. And I want to make sure that I'm separating the whole number from the fraction. And if it helps you, make this line that separates those a little thicker. And then for the width, I need 1 full-size row and then one that's a little bit smaller for 3/4. So I'll label my whole as 1 and my fraction 3/4. And again, make that line a little bit thicker so you can see the 4 parts of your area model. Any questions so far on how I'm building my diagram? Okay. So now that I have this area model, this is what I'm going to use to make my math equation. So the last time I did it using my 2 mixed numbers and my multiplication expression, this time let's start with the diagram. So if I look at my 4 different rectangles here, the first one, this big one, if I wanted to find the area of this part, I would multiply the length and the width, which is 3 and 1. So this is 3 times 1. If I was looking for the area of this box right here, I would be multiplying 3/4, which is the length, times the width, which is the same as this one, that's 1. So 3/4 times 1. Can somebody help me figure out what I need to multiply to find the area of this part?
3/4 times 3.
Perfect. And And what about this last one?
3/4 times 3/4.
Great job. Okay, so now that we have a math equation and a multiplication expression inside each of the 4 parts, those are your 4 parts that go in parentheses when you write your expression. So I can do 3 times 1 from my first box, 3/4 times 1. My next one, I have 3 times 3/4. And then 3/4 times 3/4. So this is where drawing a model is nice and helpful because you can visually figure out which things need to be multiplied. And then we just write them in a row, really, adding each of those expressions together. Okay, so then we just start to multiply. So 3 times 1 is 3. 3/4 times 1. Well, anything times 1 is just itself. So that's 3/4. Plus, I have 3 times 3/4. So that would be 9 over 4. 9 over 4. That's an improper fraction. So what would 9/4 be equal to?
2 1/4.
Great job. Because 4 goes into 9 2 times. That's 8. 9 minus 8 is 1. So 2 1/4. And then my last set of parentheses, I have 3/4 times 3/4. So to multiply a fraction times a fraction, I just multiply the numerators and then multiply the denominators. So 3 times 3 is 9. 4 times 4, 16. Okay, now I have to add these 4 things together. Can I do that the way that they are right now? Jimmy, can I add these the way that they are right now?
I think they're still all trying to write things down. Jimmy's ready.
Yes.
Jimmy, can I add these the way they are?
Yes.
Think about when I add fractions, what has to be the same about them? Do you remember what has to be the same to add fractions?
The denominator?
Yeah, the denominator. So I have 4ths and 4ths and 16ths. So can I add these the way they are right now?
No.
No, I have to change these denominators. So I know that I can multiply 4s to get to 16 because 4 times 4 is 16. So I'm going to rewrite this row, 3 plus, but now I want to multiply this, make the denominator 16. So I'm multiplying 4 times 4 to get 16, which means I multiply the 3 times 4. So 3 times 4 is 12. With my 2 1/4, the whole number stays the same, but I also have to change this fraction. So 4 times 4 is 16. 1 times 4 is 4. And then 9/16 can stay the same.
Remember, guys, it's going to be really important that you keep all of your numbers organized the way Miss Hall is, where they're all in a straight line, so that way you aren't mixing things up.
Okay, so I'm going to add my whole numbers first. I only have a 3 and a 2, so that equals 5. And my denominator will stay the same. So I just have to add these numerators. So 12 plus 4 plus 9. So 12 plus 4, I get 16 plus 9, so 16. I got 25. If I'm wrong, let me know. And I have a numerator that's bigger than the denominator. 16 will only go into 25 one time. So I'm going to add another whole. So this becomes 6. And then if I used one group of 16, how many are left? So 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I have 9 16. So the area is 6 and 9/16 square units. Remember, if you have any questions and you're having trouble unmuting yourself, go ahead and type notes into or questions into the chat section because Mrs. Nowitzki and Mrs. Bloom are here monitoring that too. All right, so for rectangle C, we're going to make this 1.5 units long and we'll make it 3/4 units wide. So we're going to start with drawing the model. So for my length, I need 1 1/2. So this one's pretty easy. There's one hole, and then this is 1/2.
So Miss Hall, are you just choosing any numbers to use?
I'm giving them the numbers to use because if we were in class, I would have different materials with preset measurements. So I'm just giving them the measurements.
Okay, so if they wanted to try rectangle D later, they could just choose whatever measurements they wanted.
Well, we're actually going to do D with a different one.
Okay.
But yeah, anytime you want to practice, you can just pick out a different length and width and go ahead and draw it and practice. So maybe in my diagram, I might have made this a little too tall, but this is only 3/4. There's no whole number here. So I only need one section. I don't have to draw another line going across because there's no whole number to separate from the fraction. So here I only have 2 parts of the area model that I need to find. So again, I'm going to use the length times the width. So in my first box, I'm going to multiply 1 times 3/4. And in the second part, I'm going to multiply 1/2 times 3/4. What's on the inside of each one becomes my multiplication expression. So 1 times 3/4 plus 1/2 times 3/4. So if I multiply 1 times 3/4, remember 1 times anything, it just stays the same. So that's 3/4 plus, when I multiply 2 fractions, it will start by multiplying the numerators. So 1 times 3, 3, 2 times 4, 8. So I have 3/4 plus 3/8. I cannot add these yet because what is not the same?
The denominator.
The denominator, exactly. So I don't have to change both. I only need to change one of them to make them the same. I can multiply 4 times 2 to get an 8. So,
Miss Hall, can you slow down a little bit, please?
sure.
They're just all trying to catch up with the writing.
Yeah, no, thank you, because I can't see them when I have this on my screen. So, thank you for telling me.
I feel like these problems have a lot of steps to them.
They do. It's putting together a lot of things we've done in the past in a new way.
So right now you're finding a common denominator.
Yep, I'm finding a common denominator, so I'm going to multiply 3/4, both the 3 and the 4, by 2, because 4 times 2 will give me an 8. So 4 times 2 was 8, 3 times 2 was 6. This 3/8 I don't have to change, because now the denominators are the same. So since my denominators are the same, I can add. Remember when we add, denominator doesn't change. I just add on the top. 6 plus 3, 6, 7, 8, 9. Get 9/8. What's the problem with this one? I have a numerator on the top, or a numerator that is bigger than the denominator. So we have to change to a mixed number. What are we going to do?
You're gonna change it to 1 1/8.
How'd you get that?
Because it's one whole. Because it's 8 and 8 is one whole, and it's going 1 over, so it's 1/8. You're just using the denominator and
Great
putting
job,
it.
Ava. Good explanation.
You know, I like how they team that because Zach said the 1 1/8 and then Ava did the explanation.
Yeah, that was great.
And Rowan had it in the chat.
Nice. All right, I'm going to give you another one. Three-fourths units long, 1/2 unit wide.
Okay, so let's take a pause for a second while you guys get yourselves organized. You can try and draw it.
And you'll notice this one doesn't have any whole numbers. These aren't mixed numbers. So that's kind of eliminating one of your steps. So since I don't have any whole numbers to separate from a fraction, here I just have to label each side. It's 3/4 unit long, and it's 1/2 unit wide. I don't have to separate anything. Here, I had to separate because I had a whole number and a fraction, so I had to split them up. But here, there are no whole numbers, so we just label the sides with the fractions. And then if I look at what I was doing in my other problems, I was finding what would I multiply to find this box? What would I multiply to find this box? Well, in this one, there's only one box to figure out. So all we have to do is multiply the length and the width. So that would be 3/4 times 1/2. So when I'm ready to multiply, that's all I have to solve is 3/4 times 1/2. I don't even need parentheses here because I'm only solving for one expression. Can we have somebody help us solve this one?
Alma would like to, or unless Zach
Go for
Zach
it,
was
Alma.
going to, but go ahead, Alma.
So you multiply 2 and 2 with 1/2, and then you'll get
Wait. Oh, I see what you're doing. You're trying to make these common denominators.
Mhm.
Okay. We don't have to do that, Alma, because we're not adding.
Right.
All we have to do is multiply. So what should we do to multiply?
Multiply 3 and 1, and then 2 and 4.
Okay, so it's 3 times 1.
3,
Yep. And 4 times 2.
8.
Great job. So our area is 3/8 square units. All right, when you're ready, go over to the second page. We're going to do one more problem. All right, so number 6. A square has a perimeter of 51 inches. What is the area of the square? Okay, so a square. What do we know about a square?
And this is good because this is going to help you for our next units coming up.
It's got 4 sides.
What's special about those sides?
It's the perimeter, so we can just divide 51 divided by 4.
Why would I divide it by 4? I think I heard someone else kind of say it.
Yeah, Mario did.
Mario, what's special about the square?
The width and length are all the same.
Yeah, all the sides are the same. And perimeter, Zach told us, is all 4 sides added together. So what we can do to find the perimeter is we can take 51 and divide it by 4. What's another way that we can write a division problem? Instead of writing it like this, hint, hint, look at what the symbol looks like.
We could do long division.
We could. What's another way we can write it, though?
We could write it as a fraction.
Yeah, we can write it as a fraction. So 51 over 4. Here I have one of those pesky numerators that are bigger than the denominator. So we have to figure out how many times 4 goes into 51. Any ideas?
13.
12? 13, let's see. 13 times 4. That's 12. 4, 5. That's 52, Riley. That's a little too much. So what else should we try?
12.
12? Let's try 12. Let's check it out. 12 times 4. 4 times 2 is 8. 4 times 1 is 4. 48. That works. So our whole number is going to be 12. We had 51. We used 48. So what's left over?
3.
3. Okay. So that means each side is 12 3/4. Have we answered the question?
No, because we haven't found the area yet.
Right. So how do we find area?
12 3/4 times 12 3/4.
Yeah. The length times the width. So 12 3/4 times 12 3/4. Okay. So you've got two options here. You can do what I did the first time and just do like a distributive property, or if those pictures have been helping you, draw yourself a picture. And I don't have to draw every single tile, okay? I can just separate the whole numbers. So this is my 12 from the fractions. I don't actually have to draw in 12 boxes. And then I would do the same thing on the side, 12 3/4. I don't need every single one of those boxes drawn in because I know that to find the area of this box, I'm going to multiply the length and the width. So what am I going to multiply in this box? My length and my width is going to be 12 times 12. Can somebody help me with this one?
12 times 3/4.
Yep. Nathan Bracey, I think I saw you here. Can you help me? What would I multiply in this box?
Uh, 12 times 3/4.
Great job. Nice work. And somebody I haven't heard from, aka not Zach. What do I multiply in this box?
How about Julie?
Julie.
3/4 times 3/4.
Perfect. Okay, so you guys, after you've done this work in your area model, what the heck do we do with all that information now? Is Nathan Harrington still there?
He is here.
Can he tell me what I'm supposed to do with all these things in these boxes?
Multiply them.
I'm going to have to multiply them. What do I multiply this times this times this times this?
I can't really see. My screen is like blurry right now.
Oh, it is?
I can like kind of see it's like 12 times 12 and then like
So that's going to be the first thing that I put in my equation here is 12 times 12. Can somebody help him out? Maybe somebody I can see better.
and then 12 times 4/4.
3/4. Nathan, what goes in between? So you told me 12 times 12 and then 12 times 3/4. What am I going to do with those two things? Do I multiply those times each other?
No, multiply the. Well, you have to take everything out, and then you multiply what's in the parentheses, and then you add that all up at the end.
Yes. Great job. We're going to add them together. So in between each set of parentheses, I'm adding. All right. So then I have these two left on the bottom. Another 12 times 3/4 and 3/4 times 3/4. And this looks like it's going to be really hard, but it's not that bad. I promise. So 12 times 12. Anybody?
144.
Yep, 144. Good job. All right, 12 times 3/4.
36/4.
Yes, 36/4. Whoa, wait, 36/4. Can we fix that up? How many times is 4 going to 36?
9.
Yeah, exactly 9 times. So instead of writing the improper fraction, I'd rather work with a 9. Now I love it when this happens, guys, because look at the next expression is exactly the same. So save some brain power. Just repeat the answer. And then we have one left. 3/4 times 3/4. Who can help?
9/16.
Yep. Okay, we only have one fraction here. So all we have to do is add together the whole numbers. So 144 plus 9 plus 9. Well, I can do 9 plus 9 in my head. I know that's 18. Then I'm just going to come over here and add off to the side. Make sure I'm being accurate. So 8 and 4 is 12. 4, 5, 6. 162. So 162, nothing to do with the fractions. That just stays the same. So we have 162 and 9/16 square inches. And then we need an answer statement, which I don't have a ton of room for, but I'm going to squeeze it in here. The area of the square is 162 and 9/16 square inches. Okay. Anybody have any questions? So, today for your problem set, it's going to be for your exit ticket, it's going to be very, very important that you are uploading and posting the picture of your work because I need to see your diagram. Okay. If you can't do that through Assessments, email it to me or text it to me. That's fine too. But don't just click that I drew the picture and leave it like that. Actually send me your picture so I can see what you're doing and see your work. Okay. Any questions about any of that stuff?
What questions do we do?
Good question. Today you're doing your exit ticket for lesson 11. It's only one figure that you have to find the area of. So it says to find the area, Andrea tiled a rectangle and sketched her answer. So tiling was what I did on the first couple where I was drawing like all of those different little boxes. I don't expect you to draw all those little boxes, okay? You can do it more like we did with this one where you just labeled the whole number and the fraction. You don't have to draw every single line, okay? But you should have a diagram that looks kind of like this. So you're going to sketch her rectangle and find the area and show your multiplication. And then it tells you that the rectangle is 2.5 units by 2.5 units. So you have to have a picture and the multiplication work. Okay? Any other questions? All right, great job today.
I can't find my.
For all your participation, great questions. If you need anything, let me know, okay?
I can't find my exit ticket. It's not in here.
It should be right after the problem set. It should be right on the back side of what you just did, problem 6.
Or the next page.